Hello students. After referring to the concept of pH, the following questions will arise into mind. The questions like uh, can pH be equal to 0? Can pH be negative? Can pH be more than 14? Well, these questions can be answered. These questions can be answered upon solving problems related to this and after defining the concept of pH. So let us now what we do is we try to solve the pH related to this situation, these situations. Let's go for first one. Let us find out the pH of say 1m HCl and 1m H2SO4. Okay, let us take up this 1m HCl. 1m HCl, we know that HCl is a strong electrolyte, therefore it dissociates completely to give H plus and Cl minus. This completely dissociates is indicated by single arrowhead. Well, it means that molar concentration of H plus ion is equal to molar concentration of HCl, which is given as 1 mole. Therefore, molar concentration of H plus ion is equal to 1 mole. Now, if we apply the concept of pH, pH is equal to, we know that it is negative logarithm of molar concentration of hydrogen ion to the base 10. This is equal to negative logarithm of molar concentration of hydrogen ion, which is 1 to the base 10. And we know this value as 0. It means that pH can be 0. See here, we are just now asked a question, can pH be 0? Yes, pH can be 0. Then let us take up another example where H2SO4 is taken. 2m or 1m H2SO4. Okay. We know that H2SO4 is also strong electrolyte. It means that H2SO4 also undergoes complete dissociation to give 2H plus SO4 minus 2. Well, this implies that if 1 molar H2SO4 is taken, 2 molar H plus ions will come. It means that molar concentration of hydrogen ion is 2 times the molar concentration of H2SO4, which is given as 2 into 1 mole, which is equal to 2 mole. Now, pH is equal to negative logarithm of 2 to the base 10, which is equal to minus log 2 is log to the base 10 is 0.301. It means that pH can be negative. See here, we have asked this question, can pH be negative? Yes, pH can be negative. Now let's go for another example. Say, let us calculate the pH of say 2m NaOH. Okay. We know that NaOH is a strong electrolyte, therefore completely dissociates to give Na plus and OH minus. This implies that molar concentration of hydroxyl ion is equal to molar concentration of sodium hydroxide, which is equal to 2 mole. It means that molar concentration of hydroxyl ion is 2 mole. Now, pH refers to molar concentration of hydrogen ion. Therefore, this hydroxyl ion concentration will not give you directly the pH value. Therefore, there are two ways to convert this into pH. One is you calculate pOH, then you convert this into pH. Otherwise, you directly get hydrogen ion concentration is equal to 10 raised to minus 14 divided by hydroxyl ion concentration. Whatever you do, that you'll get it. Okay, let's go for this one, first one. Okay. POH is equal to negative logarithm of molar concentration of hydrogen ion to the base 10, which is equal to negative logarithm of hydroxyl ion concentration. How much it is? 2 mole. 2, which is equal to minus 0.301. Okay. Now, POH is minus 0.301. And we know that pH plus POH is equal to 14. Therefore, pH is equal to 14 minus POH. This is equal to 14 minus 0.301. This is equal to 14 plus 0.301, which means that it is 14.3. Well, pH can be more than 14. That means we asked this question, can pH be more than 14? Yes, it is more than 14. Now question arises, then why we say pH range is between 0 to 14? Why it cannot be negative and positive more than this? Because just now we have seen that it can be negative, it can be more than 14. Well, answer for this lies in this fact. See here, pH is a purely mathematical concept of converting a negligible value which is difficult to remember. See students, it is small value means it will be difficult to remember. A purely mathematical concept of converting a negligible value which is difficult to remember into its equivalent larger number, so that we can remember easily. Okay, it means that pH is negative log of a very small number to its base 10. This gives considerable large number. Okay. Now here we have taken this 1m HCl. 1m is not small one, it is a large value. Therefore, concept of pH should not be applied for this. It can be applied, but it should not be applied. Are you noticing the difference, student? Can be applied, but should not be applied. Reason why it should not be applied means it's a large value. Well, the purpose of using the concept of pH is, look at this. If it is small number, then you apply it. It is a large number, we can remember it very easily. Therefore, application of concept of pH is not necessary here. Therefore, we get this abnormal value. And look at this, it is 1m. It means that hydrogen ion concentration is, how much it is? 2 mole. It's a larger number. Therefore, we will get abnormal value. Now look at this. It is also larger number. It indicates hydroxyl ion concentration. See here, therefore pH is more than 14. Therefore, students, pH can be 0, it can be less than 0, or it can be more than 0. But concept of pH is developed only for applying to very small numbers so that we can convert them into equivalent larger values. Is that clear? Hence, pH can be negative or more than 14, but it should not be like that. it should, hence the concept of pH should be applied only for small numbers, so that we can convert that into a larger value. Isn't it useful one? Well, if you like it, just give a thumb and subscribe this channel. Thank you.